Just check if I'm recording. Okay, Anna is already recording. Thank you. Welcome to our next lecture for Node.js. Today we're going to look at one of the most important topics, I think, that we can discuss during backend related lecture, which is a protocol to talk to that backend, or protocols. And in particular, we're talking about HTTP and WebSockets. Again, that's typically me, Dmitry, and I'm going to tell you about what is Hypertext Transfer Protocol, which is HTTP. We're not going to talk about HTTPS for the sake of simplicity. We're also mentioning how Node.js in particular works with that HTTP module, and also briefly mention what are WebSockets and how they related to the whole HTTP protocol things. Okay, that was unexpected. Anyways, Hypertext Transfer Protocol. We know that hypertext is kind of a word that we come across a lot during web development, and one of the most famous places is HTML, which is also related to hypertext in some way. Without going too much into detail, this hypertext thing is related to some abstraction of information that we are going to send back and forth between front end and back end. And then again, transfer. The transfer word is related to the process of communication between any client, machine, browsers, and our backend, where we have our endpoints, some useful. They're doing some useful things. We have access to a database, for example. We just transfer that information or that useful thing to another server. It could be anything, but the main point is that we have a communication link between all of those clients with their laptops and our backend, and we are using that link to transfer information. So combining this to hypertext, which is web-related information, and the action of transferring that information, we end up in a kind of a mess of how we can transfer the information, whether we transfer it raw, like just bits of data, or do we build any abstraction over our data, kind of trying to organize it. There's a vast field of how the information can be transferred from client machine computer to another machine, being a backend. And that's where the third word, protocol, comes into play. Some very smart humans thought about this problem, that if there is no kind of agreed upon solution in terms of the way of communication, we won't be able to kind of support all the different ideas that clients come up with. Imagine if there were no two people talking the same language in our world. So they came up with kind of system, and that system is a protocol, and there are a bunch of protocols for different situations. And so protocol is kind of like an agreed upon way of doing that hypertext transfer of data. So a closest analogy to a protocol would be a language in real world. So we have hypertext, or HTTP, HTTPS. We can think of them as English language, since they are kind of the popular one. But we also have other languages in our world, as does the communication in computer science, WebSockets, SOAP, and XML, kind of JSON as the way of storing data. So those are kind of like languages and accents or dialects that also used to communicate. But the main idea is the same. We're trying to have a common way that everybody agrees upon, so that we can kind of build separately and develop separately. Front end is developed in their own way, and back end is developed in their own way. But that was kind of like an introduction into how the engineering side of things worked, why there are protocols, different types of them, and why do we need them in the first place. But in the beginning, there was a mess. So we had to do something. So we're discussing HTTP, and as a language, has its own words, its own structure, its own kind of like ways of describing objects, the actions, etc., etc. HTTP as a protocol, as an analogy to a language, also has structure. So a typical structure of HTTP as a language or protocol is it has a header, which is place where I specify kind of configurational information, not the one that I want to say, for example, a bird, but where I specify, okay, that's an animal, and this animal can fly, and etc., etc., kind of giving more context to the thing that I'm going to say. And then body, which is actual words that I'm saying, and images that I want those words to kind of explain. So very simple structure, header and body, header being a utilitarian purpose, and body, which is actual useful payload. So if we look into how we communicate, how we initiate the actual response, the request, HTTP request, we have the following structure. So request line specifies what action I want to take, where that action should be applied, using what version of language, for example, English or Old English, or I don't know, Irish or any other things. Some additional information in terms of header. So in header, I specify all those configurational things. And then there will be, if there is a body, if I want to do something with a body, it will be right below my headers. So this kind of structure is like common among all the requests. They differ in terms of the structure of the like details of headers and body based on the action I want to take, whether I want to get some information, kind of requesting information, like give me something, hello world, etc., etc. Or if I want to put that information, and that would be different. I will need to specify what I'm putting, or like sending. So as I already mentioned, an idea of that creating this type of language of the web, or one of the languages of the web, is not new. It was around many years already, almost 20 years. It had different versions, and as language versions, kind of like English, Old English, very Old English, it had different words and it had different grammar rules. That's how the HTTP versions also differentiate. The latest one being kind of like version 2 something or version 3 already, which is in draft at the moment. And that's how we kind of find a notation. A very common, since we're talking about network communication, protocols are kind of outside of development or developers' concern most of the time. It's more about network engineering, and network engineering and any kind of like academic side of things, they use something called RFC, which is request for comments. It's a RFC and then a number, which in turn specifies kind of like an ID of official published document that describes the change or describes some protocol. And the request for comments serves the same purpose. It should go through lots of network engineering minds before it published and officially adopted and supported by all the browsers and all the network related hardware and software. So that's how versions work. Then, as I already mentioned, with HTTP, we can do different types of actions like getting or putting something. We already mentioned that. And those actions in HTTP vocabulary is are called methods or verbs, sometimes called verbs, because they kind of map in on the actual semantic meaning of what we're trying to achieve. If I want to get some information from the backend, for example, a list of items, I issue the get request using get method. If I want to add something, for example, a new order in the system, I issue post request. If I want to change my profile data, for example, I issue put request. And again, delete, also a very similar one. And these are the most common ones: get, post, put, delete. We sometimes see patch. It has a very vague difference. Without going into too much details, it's kind of similar to put, but not at the same time. Sometimes we also see options request in our browsers, which is indeed optional, but it has some edge cases. For example, course issue, we do need to rely on option request for that. So this is a typical wiki page that specifies where those methods were first introduced, and then what they do. Do they need body or has body? And are they safe, idempotent, and cacheable? So a few words about the last two words. Cacheable, I think it speaks the same by itself. It's about whether you can save the results of that request in your kind of caching solution. Browsers, backend caching, and important is a kind of quality of anything that could be repeated again and again, giving the same results. So if you can rely on something being idempotent, you think that it's kind of stateless. If I do 1,000 requests, I can expect that it will give me 1,000 identical responses. If it weren't the same, that means the response would be different. For example, for post, if I add a new order again and again, at some point, I think after the first one, if everything goes according to plan, it will say that this order is already there. That means it's not idempotent. But if I get the list of or some item, that order from the backend, no matter how many times I issue that request, it will always return me that order. if it's present, obviously. So that's two things that we need to mention. Going back to HTTP, depending on the result of my action, so anything that I can use here, so HTTP method I can use here, I get something returned or some acknowledgement of my action. And depending on a special field in that response, and response looks something like this. So it will be also headers and some body. So this thing, 200 OK, is a kind of agreed upon status of my request. To specify whether it was success or it was an error, which site that error occurred on. Was it a validation error, meaning that I issued something incorrect, or was it something that happened on the server and I just need to, I don't know, if I'm front-end developer, I just need to wait and maybe yell as hard as I can so that backend developers actually go and fix the issue. So it kind of, these two status codes, they denote the required action on what side, whether it's on the front-end side or back-end side. Success is the most common thing that most developers dream to see in their status code response. Redirection and information, not kind of like hard related to what we're discussing now. Just think of the status code as machine-friendly way of specifying whether we succeeded in our request or something went wrong, without actually needing to look into our body and decide every time whether we got what we needed or it's something different. So headers for every request, as well as responses. They also have kind of grouping present. We can specify different kinds of headers. They serve different kinds of purposes. For example, the most common, I think, header would be authentication. It is used to pass the token so that backend actually recognizes us and says that we can do certain things. We also can specify caching, client, hence connection management controls. Cookies is another way of authenticating. This one is for JWT or bearer tokens, and this one is for old school cookie session things. Annoying header. Not going too much into that. So there are lots of groups of headers. Groups are just the names for the header, and the value is up to you, just so you know. So that's kind of a brief introduction. Quick note, HTTP as a protocol, it's a communication with some front end and some back end. It doesn't mean that we are doing necessarily Node.js on the back end to use HTTP. JavaScript world kind of implies that we use JavaScript on the front end. However, backend can be written in Python, Java, .NET, anything, even the old school other types of languages, maybe some C code. Doesn't really matter because HTTP protocol, being a language of communication, kind of solves the issue of abstracting away the actual implementation of the backend. So going back to Node.js world, a lot of details. We either have using HTTP protocol, we either have a way of issuing some strings and combining or constructing our request every time we want to do that. That means we every time need to pass accept language string. And then when we get the response, we need to kind of parse it to understand where the headers are, where the body is. That's kind of annoying to do. So some time ago, I believe it's a standard library. So Ryan Dahl, who created Node.js, thought about this usefulness of having a library that does all that HTTP related stuff for us. We just need to kind of use it. So, and that's how it looks. So just briefly reading the code that we see on the screen, we are requiring, using CommonJS, we're requiring a module and issue the .createServer method or function, we call it. And then wherever the result of that function call will be stored in the server variable. Not the most popular way to write this type of code, but anyway, it works. So the server, as usual, it's an object that has lots of different kinds of fields, one of which is .on, which is a very typical notation for anything event related, as we know, in Node.js and JavaScript in general. So it also has .on. It can specify the name of that event that will happen somewhere internally. And then we specify what should happen, in our opinion, when that event is issued. So what we're saying here is that whenever we request, we need to kind of get the URL from the request. We want to respond using res something. We want to respond with additional headers. So we're setting a new header. You'll have its default ones, but we're setting new header being application JSON. So we want to kind of reply with JSON, and whenever whomever or whatever is reading or receiving that reply will know that it deals with JSON data. Then we set the status code to 200. So manually saying that, hey, that's a success. And then we end, meaning that we're kind of sending the response to whomever requested that, a payload with a URL that we passed. So we're basically kind of like echoing. We make a request to, I don't know, google.com/users, and we receive the reply in JSON format containing that google.com/users. Silly example, but anyway, that's a useful part of our server. So we're saying that our server is smart enough to do one little thing. And then we say, hey, server, listen in this port. And we're finishing our JavaScript program with a console log or process.stdout.write, which is almost the same thing, saying that server is running on this port. That's it. So the server related or HTTP related stuff is only here, where we create the server, then we specify, hey, listen to this, and then on what port. That's it. That's how we use it. All that we've talked about before, about specifying the request, somehow passing the response, all happens somewhere on the background. We're just specifying some additional stuff. Okay, a bit more complicated example. To do kind of like, or to serve static files from the previous lecture we discussed, we can also require fs, which is a create read stream. Then again, we're specifying one kind of endpoint for that whole thing. We're extracting URL in the method, and based on them, if we're getting something, so we're issuing, hey, get me the page, we are looking for the index page. If the root was /, so in our previous example, google.com slash or without slash would give us an index HTML file, and we are setting content type so that browsers can understand that this time it's not a JSON, this time it's an HTML that gets returned, and we are returning the content that we pipe from the read stream, which is an HTML file. This if statement is actually a way of, like, an old school way of specifying endpoints. That means if I want to have /users, I would create another if statement specifying URL /users, optionally specify what method I want to kind of react to, and then doing the useful stuff during the brackets. We're ending our response with res.end. Since we are kind of like finishing the response and we are returning from the server.on in case we are successfully serving the index.html, we don't need to pass anything here. But if we didn't find what we're looking for, we need to issue the status code 404, which indicates that, hey, whatever you were looking for, slash is not present. We don't have anything at the root level. That's kind of what was a way to do old school static style serving using HTTP and FS module. Okay, next example would be brief introduction. What would be an HTTPS? Nothing too deep here. HTTPS is just a secure way of doing the same thing that HTTP does. It just requires you to have a certificate. The next thing is an error handling. So we've seen that we can specify what requests we should be looking for, but in case of an error, we are also, it's an event, so we can also specify what should happen if we have an error in our system, and that's how we do that. So server, if it receives a request, so that's this part, it should execute some function. Then inside that function, we get the request and response. They are objects, as we've seen already. So res.end, meaning that there is a method .end set header, also has implies that set header is a method of res. So they are objects. And we also have an ability to set events. I'm sure that it uses event meter under the hood. So by issuing .end, .on and specifying the error, we can also pass the handle for the request error, same thing for response error, and then do whatever we want with that thing. We also can specify the server level errors and handle them. So in general, kind of like a spoiler for you for one of the next lectures, error handling for backend means that we do something when some errors happen in the system. So we kind of, it's not error protection or error prevention, not this, because error protection or error prevention means that we can basically protect our code from having errors by writing good code. But if we kind of miss something, if something unexpected happens, we need to at least handle that error. And by handling, I mean log it, gracefully shut down the server, maybe issue some analytics, and then maybe start another server. But that is usually done by an outside system. So the one that launched this application or this server in the first place. But at least we are logging, we're shutting down gracefully, and we're issuing analytics. And by the way, gracefully shutting down is exactly what I just mentioned about logging and metrics. We don't want just to throw an error and immediately exit the process. We want to retrospectively kind of understand what happened before we shut down. That's what I mean when we are specifying request, response, and error or server handlers. We want to know what happens if that was a request error. We want to know what happened if that was a response error for a particular request. And then we want to know if something happened with the server itself. Maybe it got overloaded, it ran out of RAM or something like that. Which is not necessarily related to any requests. It's just in general, servers have their own errors. So handling errors again, logging, and maybe analytics. Okay, since we already mentioned WebSocket as being a protocol, I thought that we can cover WebSockets as another way of establishing communication with our backend. Before going into the details, how they technically differ, I think a really important thing to understand is the engineering side of different protocols. So HTTP, as I mentioned, it has some methods: get, post, put, post, delete, something. And when that action succeeds, we get the response, meaning like, hey, everything went well, or everything failed. And that's it. So it's a discrete one-time operation usually. And if we want to get another data, we also creating a request, issuing that request, getting response, and then again, communication has ended. And that is kind of if we on the whole planet of Earth, we were saying one word, one sentence, one at a time, while all other humans kind of silent. That doesn't usually how it works. And we also want to be not the only ones who are saying something. We want to hear from people, their story, for example. But HTTP is usually done from client to backend, because clients are many and the backend is one. For example, we can't issue something directly to all the clients or to a specific client. That would be kind of a security bridge for a client. So HTTP doesn't really solve the issue of back and forth communication between client and server, server and client, and at the same time handle lots of different clients and different servers. That's where the WebSocket comes into play. So WebSocket is a specific way of establishing communication link or communication way where it doesn't end when I said my part. HTTP, if I say something and you acknowledge that you heard that and you respond, that's it. Communication is kind of killed. In WebSocket, we are establishing a constant line of communication where I can say whatever I want, you can say whatever you want, and that's how we communicate. That's kind of a dialogue, and HTTP being a monologue. All that aside, how does WebSocket differ from HTTP? The difference is not that big, because we're using almost the same notation. We're issuing, hey, we're saying like, hey, I need to get something. This is the address, this is the protocol. However, I want to specify that persistent link that will stay open kind of and wait for us to continue chatting. And that's not the random word that I used. This is the main way that we kind of use WebSockets for chats, for something that should do a back and forth communication both ways. Whether my friend is writing a message to me and I want to see when that happens, or whether I'm writing to my friend. But that's how it's done. So we're specifying that this is the version of WebSocket protocol, and this is the actual protocol I'm using, chat or super chat. They're a bit different. And that's what I get in response when I'm setting up that connection. So this is to set up the whole connection. This is a key to kind of make it unique in kind of environment. And that's what I get in response, saying that, hey, we understand that this is a not kind of like one-time connection. This is a WebSocket connection. It will be upgrade version, which is kind of like if it dies, we're re-establishing it. And we acknowledge that everything will be done with a chat with this kind of secret key that we're passing. So to have my analogy mapped into or onto the actual theory, when we're talking about WebSockets, we're talking about full-featured duplexes stream of data. What we mean by full-featured is that it's a complete protocol. It's not just some kind of experimental thing that we are just adopting. It's a full-featured way of doing that, and you can see that by recalling how many apps for different chats that we have today. Duplex stream is that data is assumed to be never ending, meaning that I don't kill connection when I receive my chunk of data. I always expect that there will be more, just like streams. And duplex means that it's both ways. It's not just clients communicating with backends, it's also backends communicating with clients. Think of it as, for backend, being a, I don't know, a common place for all the clients to store their messages. And whenever one client stores a message dedicated to another client of the same backend will initiate a message notification, and it will find who the client, the target client is, and will send that message to their client application. That's how it works. It's bidirectional, as I mentioned already. Connection being like always there. However, it can be closed from any side. We use the WebSocket protocol to handle real-time web applications. It's not just chats that exchange messages. It's anything that should be kind of like updated on the fly without reloading the page. There are the WebSocket being a protocol, as HTTP being a protocol, they both have different libraries and frameworks built on top of them. So like one of the most like well-known for HTTP communication or server initialization is Express.js. For WebSockets, that's maybe one of the most important frameworks or libraries is a socket.io, which is a framework built on top of WebSocket and handles lots of stuff that is not handled in WebSocket per se. But since that's relatively new compared to HTTP and HTTPS, we always need to kind of like keep in mind the browser support. It's not the latest and greatest like table of all the supports that WebSocket had as a protocol, but most of the modern browsers, they support that way of communication. They're not as dumb as to support just one HTTP and only, but you need to kind of have that in mind when you do socket. And since I mentioned the library for web socket protocol, this library is socket.io. We have an example of usage of that library. So we're requiring socket.io. It returns the function to start kind of the connection. We specify that the connection server will live on 18 port, and that's where we get the input output or IO object. We also require a specific library or specific stream with their own kind of like objects that they understand to kind of simplify the way that we're using socket.io. And that's what we do. We use that helper library to create a new Twitter kind of session by specifying lots of stuff, the credentials, the token. Most of the systems like Facebook and Google, they all have their own way of doing that, but the idea remains the same: to create an instance of communication or a server of communication in real time. We need to create, use their own solution. And then we say that, hey, that instance of communication will be using socket.io as the way, or as a transfer. It will track the JavaScript. So we're saying that, hey, there will be JavaScript notation. And then we are saying that whenever the communication is used, transfer it using the IO. So it's kind of like you can think of the whole setup being the following: IO is the road and Twitter is a particular car. We are specifying the specifics of that particular car, and then we say, hey, you'll be riding from on the road number like 42, screaming JavaScript, I love you. And then whenever you write or whenever you tweet, please do that on this road. And since that's just a road, and we know that in real world roads are not just one way, we can go back. If it's 2-lane road, that's how we're using IO from socket.io for that. So 2-way or 2-track road. And that kind of concludes our discussion of different protocols. I've got a bunch of links for you if you want to go through them. And that's about it. Let's look if we have any questions related to WebSocket or HTTP. Okay, yeah. Go.
Since there is no chat, just letting you know that maybe some other guys would have questions and they cannot speak.
Okay. Yeah, sure. If anyone wants to kind of like unmute and ask question, yeah, feel free. Any practice? You want to know if we have more examples, or what do you mean, Vladimir? Or we want to, can you write some code? Yeah, I do can write some code. What exactly you want me to write? Or you want to kind of look how the HTTP works if it's not on the slide, but in the real VS Code or something. WebSockets. Yeah, sure. But maybe you have a particular question that you are expecting to solve. Real example, Was that example not real when we're trying to do a Twitter-like communication? And by the way, I think we need to talk about, like, while you coming up with the question that you are interested in knowing about sockets, I'm going to mention that there will be a homework that we're going to have. The homework will include several tasks, 4 tasks. It will cover the most important topics that we have in our Node.js discussion. So there will be a file system read and write operations, which is the first homework. Then we'll have a second homework, which is all about creating an Express server with kind of like a basic setup. And the last 2 will be about adding some additional features to that server and adding good practices or logging and a bit of error handling. So don't worry if you whether you're going to use the WebSocket code or not. There will be just an HTTP protocol for that brief introduction of Node.js, or being 7 lectures. I don't think we have more time to dive deeper. But if you have any like interesting questions that I can cover, please write them in the chat or unmute and ask.
Yes, so maybe you can just go through each task, at least for the very first task, which is for Friday. I started to do it today, and at task 1.2, we're supposed to use CV to JSON package.
Yeah.
And there is a requirement not to load all the content of CSV file into RAM via stream. So I started to dig out today, and I'm not sure how the CV to JSON package actually will read that. What I have done is like I created the CSV function. I'm providing the file from file and then subscribing, providing then like JSON and line number. So is that reading by line, or I'm still loading the whole file and then like pushing it line by line to stream? I'm not sure how it's actually being proceed.
Okay. I can answer that in 2 ways. So if when I was closing this presentation, I think I saw the pipe somewhere. Yeah. So when we have a stream of data and we're piping it somewhere, being a result object or a writable stream, this is a stream. It works on chunks and buffers under the hood. We don't actually store the result somewhere. If I were to create a variable and store the result in that variable, then do something with it, and then pipe, that would mean that I need to wait until the whole stream is kind of processed. So I'll get all the data, and then I store it in the RAM, being variables. All variables live inside some kind of temporary memory. And then I process it and I pass it somewhere. When I use pipe instead, whenever I have new data available, remember the previous lecture, I immediately pipe it to the writable stream. So if, for example, if you were to open read the data location index file and your end location or write location, you would see that on the write location, you will be reading chunks of index HTML, and then chunks will appear on the write stream. So that it's not necessarily you are reading it as a whole. It will take time to read through the index.html and at the same piping it. So answering your question, to not store anything in RAM means that you don't read to a variable and then do your operations with that variable and then create a writable stream and then writing it. You pipe them directly. So does that make sense? Yeah.
Yeah, it does. Just, is there a way to actually check that I'm getting a stream object somehow?
What do you mean? Like, so, is there a way to check if you're reading it one chunk at a time?
No, for example, I require like the library, right? CC to JSON, and I'm calling a method.
Okay.
And can I make sure that the method I called, the result is a stream?
Yeah, like typecasting or type def in JavaScript, as you do with any is that a function or is that an object? So I see where you're going with that. When you create readable stream, you specify the source, and then you specify the kind of like the end result or end place or target place. Between that, the read stream and the end place, you can have a transform stream. That means the transform streams, they usually work with chunks. So they will have a almost similar callback as we have with server. It will have chunks passed to that callback. You can then manipulate the chunks and then return them, and they will be passed to a writable stream. So think of it as assembly line. So instead of kind of waiting while you read the car, I don't know how to come up with a better example, without waiting to read the card to kind of, I don't know, paint it red, you are painting different parts while you are disassembling it and then assembling it in the new place, if that makes sense. So think about the transfer stream or transform streams to work with chunks. That way you will have not polluted memory and the RAM memory, using variables. And at the same time, you'll still work with streams, with chunks of data, one at a time. Does that answer your question, Leah?
Yeah, I think, yeah.
Okay, streams in Node.js is a hard topic. You kind of need to think of the way you mentally visualize how data works. We're used to having variables for everything, for objects, no matter how large they are. But when we come to the point that objects are too large and we need to use some network communication, which can be slow, we need to a better way. And a better way is to divide and conquer, as Romans say. Divide that big data into chunks. They should be kind of like equal in terms of that they could be sent in any order and then assumed in any order, and they will still have that structure, and that will happen automatically. So you don't need to think about that order of operation, but at least they need to be kind of like transformable. So while working with transfer streams, you will realize that some operations over the data, no matter what data is, some operations kind of work with, how to say that, without bloating you with too much terminology, some data and some actions on that data will be changing that data. and depending on the data size, there will be different kinds of outcomes. It's sort of like having A plus B being not equal to, there is a famous thing, I think A plus B, C and C plus B, C. I think that's about it. So
You don't
yeah.
share the chat.
Yeah. I know. I'm just trying to come up with a good example. In mathematics, I think that's what the basis of the whole thing with streams and transform streams. Take a look at the chat where I did kind of like a strange expression where I say that f of a plus b not equal or maybe greater than f of a plus f of b. And that's kind of the same idea. If I have this a, b, not being chunks, my chunks, if I say that the result data cannot be divided equally, and the result of that function is not equal to the sum, that means transform stream would not work. Think of it as if I'm reading a text and if I want to make the whole text be uppercase, if I'm reading chunks of being like separate words and I make them uppercase, that's perfectly fine. Whether I'm reading the whole text all at once and making it uppercase, or whether I'm reading word by word and making them uppercase and then combining them, that's okay. That's a perfect data to work with transform streams. But if I'm working with a musical file and I want to, I don't know, do some strange transpilation of my music data, transpiling a whole song, for example, be one tone higher, is not equal of doing the same with chunks necessarily. And it's a weird mask, but the analogy stays the same. I need to kind of have my data being homogeneous. Homogeneous data. Homogeneous data means it's the same operation will result whether it's applied on the whole data or whether it's applied on the chunk of that data. I think that's the right word for that. Let me just homogeneous data and heterogeneous data. And there's a cool way if you want to look into more details of what I'm talking about. Okay, let me just copy the string. Yeah, Stack Overflow, perfect. So if anyone interested, I just pasted the link to the chat. You can check that out. But in terms of data science and the world of those streams, some edge cases would not work for streams, and we need to think about them before we do any transformation of our data with chunks or transform streams. And that difference lies in whether we work with homogeneous data or heterogeneous data. So keep that in mind. Any other questions?
Seems no.
Yeah. Seems no other questions. That's a hard topic. That's kind of like going beyond what we're trying to work here. As with the case of WebSockets, WebSockets as a topic was mentioned just to give you an idea that HTTP is not the only thing that we work on backend. But anyways, the deadlines are set for the homework. The themes or the topics that we cover during lectures, they are connected with your home tasks. So be sure to go along and attend lectures. That will be really useful for you. Okay, so that's it for today, and I see you on the next lecture. Bye.